this video, I will talk about Python and QGIS, especially about processing algorithms. If you want to know more about Python and QGIS, you can visit this website by QGIS Developer Cookbook. So I'm not going to talk about everything by QGIS, but only about these processing algorithms. So using processing algorithms, we can automate many GIS tasks using QGIS. So in this video, I'll talk about land use analysis and we will use modest data. So in this exercise, we will find the annual land use changes of a given area, or we will call region of interest, or ROI, and its different zones. So before you start this video, you should be familiar about raster data and also about NDVI. What is the purpose of NDVI? So uh, in the learning goals, I have written 2 points. So we will learn processing tools and how to automate those processing tools. Here I have written the steps. So first of all, we will download the modest data of the given ROI and then merge the modest data bands spatially. Clip each merged data to the region of interest, then calculate NDVI for each year, and then we will classify the NDVI, and then we will calculate the zonal statistics, and then create graphs and charts. Now let us start the exercise. So first of all, I have this area of interest. It is the map of Nepal, and it has the provinces. So I will do the analysis in this region and find the change in land use by the states. So we will learn these things here, written here. So first of all, we are going to download the modest data of the given year. So you can find this how to download the modest data from the website. So you can visit this YouTube website. So I have here 5 minutes video which explains the steps of downloading modest data. And also I have a few videos for this analysis, but it is done without any automation. So in this video, I will tell you how to automate all the processes. And here it is Earth data. So by writing here mode 09Q1, you can see this surface reflectance data, and you can go through this website to know what is this data all about. So I am not going to explain all this in this video. So first of all, I have already downloaded this modest data of 33rd day of years 2008, 12, 16, 20, and 24. So it is around 2nd February for each year. So how the land use change in the same season every year. That is the purpose of this analysis. So let us try this here. So first of all, I put this directory in my favorites. Uh, so this will be in my favorites. So I can see this uh, data here. So inside modist, I have all the MODIS data, so I will choose one of this, or all the mode 2008. So four data sets I will bring here. So for each data set, I will choose the first two bands. So we can see this. So all the bands are displayed here. So each year we have one data set, and each data set has band one and band one and band. So we have to specially merge these four data sets so that it can create the data set for whole the country. So if you are doing for different area, so you should remember how to merge the data set spatially. So I can put it above all this, so we can see that this data is here. The region of interest is here. So first of all, we will learn how to merge the data. So we are going to merge the data of year 2008, and first we will merge the data set of band 1. So in the processing toolbox, we can find uh, create virtual, so build virtual raster. So we will search build virtual. So under this GDAL, we can find build virtual raster. It is same as this uh, build virtual raster. So we will use the processing toolbox, and we will run this. So let us suppose we are going to merge the band 1. So we will select P01 for each year, and then everything we will keep it as it is. Only we will uh, set the output file. So I will create one folder named merge, and in this merge dataset, I will write the name of output. So merged 2008 E1. So we should keep the file name which we can remember, and in this I have given the year and band name. So it will be easy to remember. So this is all. So by running this, you can see that uh, this is the merged output is here. So to automate this process, we have to use these parameters. So here I am going to copy this parameter, and in this plugins, Python console, here I create a new file. So here I paste this. So I name this, this is a dictionary. So you can name this dictionary. So for example, parameters equal to And for the readability, you can break it at some places. So this is the list of data which are merged. So after each comma, I will separate it. So if you change this bench number and year value like this, so 2008 to 2012, then probably we can rerun this program. So how to run this algorithm? So we can check the name of the algorithm. So let us close it for the time being. So I will save it first to create a new program and merge dot py. So we should check the name of the algorithm. So it is ZDAL build virtual raster. So in this, so I have already created this. So uh, I will just copy the name of this. This is the name of uh, algorithm, and we'll use the parameters. So I'll copy here. So processing dot run, and then we write the name of tool, and then the variable which have the parameters. So if you change this uh, B1 to B2, all this to B1 to B2, including the output, then if you run this, so it will create uh, the new data set. You can find this merged data, V2 is also created. So in this way, we can do the programming, but it is very cumbersome because we have to change the file name and band name every time. So to automatize this process, we will do few things. So first of all, uh, we list all the MODIS data in the directory using this function. So this function gives the name of all the data for the given year. And we will use bands. So we will output this band name. So we don't have to repeat this names of our MODIS data file. So let us use this file. You can just create by writing, it will help you learn how to write the Python program. And now we have this function which produces the list of Modis data files and this extra keywords. So we can see that these extra keywords are added from this function. So we have to provide the directory path and year and band. So let us try this list, how to produce the list. So let us say directory path equal to, and I copy the directory where the Modis data is kept. So I copy this one and put in a single quote. So for the Python, we use slash, forward slash instead of backward slash. Just remove the forward slash and replace with remove the backward slash and replace it with the forward slash. And we get this variable lmodis equal to from this function. So directory name we provide from this variable. Year we give 2008 and band name we keep in quote, so B01. And if you print this lmodis, then we can check. So we have produced the list of required data sets. So in place of all this here, we can replace it with the variable, this variable lmodis. So just lmodis and separate the list by comma. And now I uncomment this part, and if after completing we usually write print completed. So I put it in single quote. So let us run this one. So it produces the output for 2008 B1. Similarly, we can write 2012 B01, and you can see that I don't have output for 2012. So, but if you write 2012 B1 and run this, you can see that this 2000, sorry, we need to change the output name also. So 2012 B1. So we can see that output 2012 B1 is calculated. But if we do it in this way, then we have the chances to uh, mistake the inputs every time. If we put the year and bands, then it will be difficult. It will not be properly automated. So we provide the variables years, and that will be 2008, 2012, 2016, 2020, and 2024. And similarly, we put the bands as B01 and B02. Then we can loop through the years and bands. So let us create a loop. So for year in years, then for band in bands. So we write L modis equal to, so directory path in this 2000, instead of 2012 we just write year, and instead of this name of the band we write just band, and then we run this uh, so we have to maintain this tab to run this. So you should know this how to create a loop, and we can also remove the default uh, elements of the dictionary. So we keep input, output, and remove this part. You should know which are default and which should be added. So we can remove this part and run again. So after running this, it is completed. So we can see that, but still all the data sets are uh, saved with this name. So still it is not correct. So what we do is, instead of this 2012, we write year. So if we put this inside the curly bracket and add F here, so it will be used as variable. Similarly, this part also we put in the curly bracket and put the name band. So now we can see. So I will delete this previous data and then run this again. So it is completed. So this part we can remove and then we can rerun here. So we can see that merged data is produced. So this is how we produce merged data for each year for each band. Now next part of the this video explain about how to clip the merged data to the region of interest. So let us see. Here I have the region of interest, vector data, polygon, and then I have this uh, merged data. So for example, if I add this merged data, so we can see this here, it is merged data set, and I want to clip it to this data set. So for this, we use uh, this here we have a tool called extraction, and we clip layer by mask, clip raster by mask layer. So we can search this processing toolbox, clip to mask, clip vector, clip raster by mask layer. So you can see this clip raster by mask layer and double click here, and input name is 2008 band 1 and mask layer is state, and we use this target. I will use WGS 84 geographic coordinate system, because the original data set has sinusoidal projection. So we use WGS 84 4326, and then uh, we give the name of output. So output name, I will create one folder named as clip, and then mm, inside clip I write clip 2008.01, and the files should be saved as TIFF instead of virtual raster. So save the after putting all the information, we can clip the data set. So run this, and you can see that these parameters are used for running the tool. So we copy this parameter, and then again we create a program. So let us add one more program. So I'll break this. So as I explained previously, we can remove the default parameters. So this is all, and we should check whether output is properly displayed or not. So we can see that the out data is produced properly. So let us try to run this program. So I save it as clip.py, and then again we should know the name of this tool. Let us check. So it is shown here, GDAL clip raster by mask layer. So the same way we can processing dot run so in this case also we need to use this year and raster name. So we have to copy this some things. So let us copy this, and this time we don't need to list files, because in the previous case we had long name and we didn't know the name of the data set. But in this case we know that input is like this and output will be inside clip. So we just use the loop again for, so we can copy this part and tab this. So we need two tabs, and then we change the name of the variables to the actual variable. So we keep it inside curly bracket and keep it here, and similarly we put it inside bracket and band. So now it will use the same data set, and inside the output also we should write year and band, and then put F here, and the mask is always the same. So my data set is inside here, and now everything is fixed here. And if you like, you can print name of year for each, so that we can confirm that data is being produced for each year. So now if we run this, so it will take few seconds, and 2008 is completed. So 2012 is also completed. 2016 is also completed. So we have completed all the output of all the data sets. So now we use this clipped data set to create NDVI. So how to do that? So we have to do it first manually like before. So inside this I have this clip, and V1 is band 1 is already there, and so I will use this band 2. So using this band 1 and band 2 I create NDVI. So there is a tool called i.vi. So inside grass, if the grass is not uh, visible or displayed here, we have to check this here. So in this install toolsets, you have to check this grass GIS provide. Then it will be visible. So we'll use this i.vi, and name of red channel is band 01, and there are various vegetation index, so we are going to produce NDVI, and the NIR channel is band 2. So others we don't need, and we just put the output. So the output will be saved in a folder called NDVI, and the name of output will be NDVI and year. So we don't need the name of band this time, because we use two bands and produce a single raster. So now run this program. So NDVI is produced like this. Now we can do very fast, because we already know how the processing tool works. So we copy this one, and in the plugin we create a new uh, file and include the. So we first of all we delete the default values and name the name of variable like this. So these bands are not necessary. We need only an IR and output and rate band. So these are not necessary. So these are the necessary parameters, and this time we only need uh, years to loop. So years equal to, and use the tab, and then run the algorithm. So processing dot run, we can copy this part and change the name of uh, this tool. So we can see the name of tool here. So it is grass 7 i.py. So algorithm name grass 7. Let us check again. I.py. So it is grass 7 i.py, and save the file. So ndvi.py is saved, and then run. So you can also write. So if we run this one, but as before, we have to change this to year and add F. Similarly, we have to only change this part and add F. Similarly, we have to change this part for band red band and add F. And now, if we run, it will produce the output inside the folder NDVI. So it is being produced here. So everything completed. So now we want to classify the data set. So this tutorial will only explain what is the reclassification, and for the theoretical background, you have to check the websites how NDVI is classified. So I have created rules for this reclassification. So we know that NDVI values range from -1 to 1. So I create a new file For example, so -1 to 0 will be classified as 0, then 0 to 0.1 will be classified as 1, 0.1 to 0.3 will be classified as 2, 0.3 to 0.5 will be classified as 3, 0.5 to 0.7 will be classified as 4, and all the data greater than 0.7. So let us say 10. It is actually up to 1, but we keep it 10 so that abnormal data will also be captured. So as we go higher value of NDVI, the density of vegetation is higher. So we classify from 0 to 5, and 0 represents lower representation or no representation. It may be snow, sand, bare land, 0 and 1, and from 2 to 5 a little bit of vegetation will be added. So 4 and 5 will be probably dense vegetation, forest, etc. So we name this file as uh, record.txt. So you have to create this file manually, and now we use this record text file to create the classified data. So here you can write RECODE, and you will find inside grass r.record, and so we use this NDVI 2008 and provide the name of file to record. So we use this. So I have this record.txt, and then the output file we save as inside NDVI. You can choose another reclass 2008.tif. So the region should be 0 for default. So we don't change any default values, and then run this one. And again, as in the previous case, now we have found this reclassified data, and we copy this parameters, and again use the Python console, create new one, parameters. So again we do the same thing, repeat. So all the default value will be removed. So we have input, we have output, and rules. So this is all. So we don't need to change this rules, only we need to change the input. So we use this part again. So we copy this part and tab, and it is very easy now. We just enter year and add F, enter year, add F here, and then same way we use this copy paste. It is now easy to copy paste, but we need to change the name of this code. So let us see what is the name of this code. So instead of I.vi, we just change it to r.record. So we change this part to r dot record and run this algorithm. So I should have saved this, but even without saving, it will use this default file name. So it is better to save this file. So same program NDVI report.py. So reclassified data is also inside the same folder. You can keep it in different folder also. So now we use this reclassified data to create histogram. So what histogram does is for each zone, so in case of this, for each state, we will find what is the NDVI, and now we will find the land use distribution for each state. For example, what is the land use for class 1, 2, 3, 4, 5, etc. So that is done by using zonal statistics. So we will see what the zonal statistics produces. So before that, I will save this data to a different geo package. So land use analysis dot gpk. So we'll save this map. Okay. And we can copy the style and paste here and remove this part. Now we use zonal statistics. So this is raster layer zonal statistics. We can check this tool name. So input layer is reclassified data, and zone layer, sorry, we are going to use different tool. So we will use zonal histogram instead of zonal statistics. So it does the same thing, but in this case the inputs are raster and vector instead of raster and raster. So we use the reclassified NDVI, and vector layer with zones are this Nepal state, and it will produce the same geometry of Nepal state with added uh, columns showing the histograms. So we can save it as different layer. So save to geo package, and same geo package we can change the name of layer. So for example, Y2008. Okay. So this will be produced by this tool, and we run this and it will be produced like this. So we can see that the step is same as Nepal state, only we have this histogram data. For example, histo 0 means the reclassified zero. For example, here record.text, so it consists of values of NDVI less than 0, which means no vegetation area, So we can see that for each state, it has produced the histogram of different land use IDs. So to repeat this process, we again use this. So I have closed this tool, so I will use the existing code. So here I have NDVI histogram. So in this histogram, we use these parameters and use the run. So we can, I will show you. So in this, we input the raster data. You can repeat by copying the log of the output of the zonal histogram. But this is repetition. So I use the RECL here. So in this tutorial, I have used different file names. So I will copy the directory path, for example. So we use this directory path NDVI and reclassified. So we need to see whether our data is like that. So RECL underscore year. So we use RECL underscore year dot diff as input, and vector data is inside this data. I have used LU analysis dot gpkg, and layer name is Nepal state. So we need to, when we copy and paste, we need to use the variable names properly. So output will be in the same geo package. So copy the geo package and table name histogram of year like this. And we use raster band 1, and we run this tool called zonal histogram. So let us try to run this one. So, but in this, for the to run this tool, we need to define the years variable. So Control C and Control V, and we have to save this. So NDVI histogram. So if we run this tool, probably it should add the layers to this geo package table. So let us try this one. So it is doing this here. So histogram .py is being run, and it has produced all the data sets. So we can check here lu analysis.gpkg. We have these 5 data sets. So for example, we have this histogram newly created one. So let us add this here. And we can create graph. For example, we can add a pie chart, and pie chart should show the attributes. So histogram 0 to 5, and we can change the color. but we can choose proper color so that it represents a greenery. For example, here. So we can see that pie chart is created like this. In the same way, we can, in this case, we create pie chart for year 2008. In the same way, we can create pie chart for different years, and we can see how each of the land use has changed for each states. We can also create a graph which shows the change in land use for each land use. Find the land use change by year. We need to join the histogram of each year uh, by land use ID. So for that, we need to first add connection to the geo package. You can find this geo package inside this browser, and we can add new connection which we already created, luanalysis.geo package. So we have this layers, and then we use the database manager. So you can refresh this to show this luanalysis.geo package, and then we can see all these layers. So we use a sample SQL, for example, to display all the columns of a data table. We use this SQL. So we need from. So this will display the data of histogram 2008. So to join the data set of different year, we need to use join statement. So we don't need all the columns. For example, we use FID and geometry, and for the first uh, land use, we use histo 0 and execute again. So we can see that only 3 layers are added. So if we want to use multiple tables, so we can use multiple tables, and then we can use a column to join these two. So instead of FID, we better use state code, and then use these two tables, and then where both of the tables state code should be same. So we write like this dot. So if we execute this one, we get this ambiguous column name state code. So it means that the state code is used in both the layers. So we should define the from which data we bring this state code column. So it is better to use alias for the table. So we say T1, and then histogram 2012 we use T2. Then we can use the column name by T1 dot state code, T1 dot geo, and we can display the column histo 0 of both the tables. So, but if we display the column of both the table, then what happens? Let us see. So instead of histo 2008, we use T1 and T2. So we can see that both are displayed as histo 0. So in 2008 it is like this, and 2012 it is like this. So we don't know by this. So it is better to rename this name. So histo 0 comes from 2008. So we write new name as uh, uh, land use type 0, and same land use hist 2008, and we can omit this LU part. So 2008 and land use is 0. Similarly, this is 2012 and land use is 0. So the name will be changed. That is the only thing that will happen. So we have to write like this. So this is the output for land use 0. But we have multiple tables 2008 to 24. So I will show you the SQL which is already created. So we can copy this, and you can just check what is written here. So I will make it bigger. So it is not district. In my previous data it was district, so I will need to change this to state code. All other things remaining same. All districts should be replaced by state code. So we will display the state code. So it shows the new column names for each histogram. In this case, I have used histogram 1. So it will display the land use ID 1 of each table and create this. There is error. Oh, okay. So now it is created properly. And we can display this as new layer. And if we load this layer, it will show in the QGIS. So we can see this. So it is added here, query layer. So we can repeat this process for each land use. So I will show you the graph of land use one only. So it is better to save this output. So in the same lu analysis.geo package, I save it as different layer. Uh, so the name of layer is histogram of land use ID1, and I save it, and I remove this query layer. Now we can create a bar chart. So let us see in the bar chart we say histogram. So we use all the attributes, and then if we apply this one, uh, we can see the graphs are created. So we need to change the rendering size. So maximum value here it is 0. So we need to find. So we use the, for example, histo01 and find. So you can check each and find the maximum. So now if we apply, we can see the graph is drawn for each year. So now we have to refine this placing of the bars. So rendering from here, we can change the bar width. So we can see that bar width, we can change a little bit. Bar spacing, we can see, check very low bar width, apply, and you can see how the width is changed, and also the area. And we can see that the area of this represented in these two states are very low. So we can little bit reduce the maximum value. So for example, if we keep it 10,000 or 20,000, then maybe the other layers will also display the area. But in case of this province, it is very low, so we don't get high value. So instead of using this actual, this histogram shows the number of cells for each land use. So instead of number of raster cells, we can use the percentage area, and then it can be displayed in the much better way. And we need to further change the colors of the graph for each year so that it gives a better display. So that is all about this land use classification and automation of processing algorithms. So we learn how to use NDVI and calculate the zonal statistics, and also we learned how to apply the Python program to automate each of the processes. So that is all for this video.